Hey guys, I want to just do a very quick lesson on calculating molar mass. So molar mass, let's get this on there. Molar mass is the mass of 1 mole of a substance. And that's going to be important in our next unit when we start talking about chemical reactions and we want to know how much are we going to put in and how much are we going to get out. It's all easier to talk about when we talk about moles. So to calculate the molar mass for an individual element, let's say my beautiful drawing here that this is the carbon box in your periodic table, right? So if we want to know the molar mass of carbon, it's just this number right here. What this means is 1 mole of carbon equals 12.011 grams, right? We are going to, for the sake of not having big long numbers with everything we do, we'll round to 1 decimal point, so we'll just call this 12.0, right? If we wanted to know the molar mass of hydrogen, we would say it's 1.0 grams per mole, meaning for every 1 mole, we have 1 gram. Right? Oxygen, its molar mass is 16.0 grams per mole. On your periodic table, oxygen says 15.999, right? That rounds to 16.0. Right? So for an individual element, no problem. Suppose we want to put elements together. We want to look at a compound. So let's start with something simple like sodium chloride. I'm going to apologize now if I get any of these masses wrong. I don't have a periodic table in front of me, so I'm doing these from memory. But I believe sodium has a mass of 23 grams, and chlorine has a mass of, we're going to round it to 35.5 grams, and we add them together, we get 58.5 grams per mole. What that means is 1 mole of sodium chloride equals 58.5 grams. So all I'm saying is if I put a sodium together with a chlorine, the mass has to be the same as adding up the sodium mass and the chlorine mass. Okay? Let's look at something a little trickier. How about if we want to say what is the mass, the molar mass of CH4? What this means is we have 1 C and we have 4 H's, right? We've drawn Lewis structures and stuff. We understand what this means. We have this carbon connected to 4 different H's. So when we add up its mass, we need the mass of 1 carbon. And then we need, so hydrogen has a mass of 1, and we have 4 of them. So we're going to multiply that to get a total of 4. And that means our molar mass for CH4, which is methane, is 16 grams per mole. Or that 1 mole of CH4 equals 16 grams. All right? Hopefully so far so good. Suppose I give you one now where we have, let's say, magnesium nitrate. So it looks like this. All right? We need to know in order to add this up, so magnesium's mass is 24.3, nitrogen is 14.0, and oxygen is 16.0, but we need to understand how many of each of these things we have. Sorry, that 6 is terrible. So we know we only have 1 magnesium. Hopefully we know we only have 1 magnesium. But what this NO3 is telling us is that we've got our magnesium here, and then we have 1 NO3 and another NO3. Right? Which means we have a total of 2 N's and a total of 6 O's. So we're going to do N times 2 is 28. And we're going to do O times 6, which is 96. And then I'm going to add this in my head. So we've got, let's see, 18. I believe it's 148.3. I hope it's 148.3 with my math in my head. But what I did was I added 1 magnesium, 2 nitrogens, and 6 oxygens. So this would mean that 1 mole of magnesium nitrate equals 148.3 grams. All right, let's try one more of those, and then I will send you off to work on your worksheet. All right, so the last one, we'll do one more where we have to distribute something. So let's say we have calcium hydroxide. All right, so what this means is we have 2 hydroxides. So we're going to, basically like in math, we're going to distribute the number outside the parentheses to everything on the inside of the parentheses, because this means we have 2 OHs, which means 2 O's and 2 H's. So calcium's mass is 40, oxygen's mass is 16, and we have 2 of them. And hydrogen's mass is 1. We also have 2 of those. We add the whole thing together, and we get 74 grams per mole, or 1 mole equals 74 grams. All right, hopefully this was clear.